This is the video tutorial for chapter 4 of my textbook, and the title of the chapter is Thermal Residual Stresses in a Cured Laminate. So the problem that we like to do is shown here. You have the 4 by 1 inch composite strip, and it's consisting of 6 plies like that, and this is a balanced and symmetric laminate, as you can see. This laminate is placed in an oven, and the temperature of the oven is raised to 220 degrees, and at that temperature we assume that the laminate has been cured. Okay, so once it reaches that temperature and it cures or solidifies, we take it out of the oven and place it in a room with a temperature of 70 degrees Fahrenheit, which is the standard room temperature. So there is a temperature drop of 150 degrees Fahrenheit from the oven to the room after a long time. Okay, so what happens is that because of the temperature drop, this thing shrinks. This laminate shrinks, and in some cases, not in this case though, because this is a balanced one, uh, it may warp. It may warp, and what we want to do is what we want to do is that once it shrinks, obviously it develops some stresses in it because the stress-free state was in the oven. Okay, the curing stage, it was stress-free, solidified but stress free. However, once it's put in the room, it shrinks and residual stresses are going to be trapped in it. Okay, so what you like to do is find out what those residual stresses is, and the dimensional change from what we had 4 by 1 into what it is now. Now, the other thing that you should mention that the material properties the material properties are given here. Okay, and I took these things from lecture notes of this gentleman up there, Professor Howard, and here is the side view of the laminate stacking sequence. Okay, now obviously because we're dealing with shrinkages and things like that, we have to specify the coefficient of thermal expansion, or CTEs, and at what temperature these reference values are given. Now this one we really don't need it for the problem. In some cases you do. In this case we don't. I'll use it, but all we need is a coefficient of thermal expansion. The other thing is that when you let this thing cool down, it will, there are no mechanical restraints acting on it. Therefore, it's free to kind of shrink, okay? So free to move as a rigid body, basically. So we're going to apply the 1, 2, 3 rule uh, to take away the rigid body motion because we want to display the displacement and stresses, okay? And here is a drawing of a case where the laminate can in fact shrink. Now, it doesn't happen to our case because our case is balanced, okay, and therefore we don't worry about it. Okay, all right. So I go to 3D Experience. We start with the part, and I'm in the generative shape design. Now I try to follow the sequence of steps that I've done in the chapter. There may be some minor differences. I try to avoid doing something like that. The first thing I did, I renamed this. I renamed this part to be video chapter 4. Okay. Now I'm going to make my part. Now notice that here I'm going to make the part and then apply the material properties. But the chapter 2, I did it in the reverse order. So it's up to you how you want to do that. In the book, I create the part. In this chapter, I create the part and apply material properties. So on a convenient plane, on that horizontal plane, I will sketch, essentials, sketch, a rectangle that's 4 inches by 1 inch. So the rectangle, which is 4 inches in the x direction. Okay, so there we are. This is 4 inches and 1 inch in the width direction. That's pretty much it. So there's my sketch. We exit, and now we're going to go to the tab, surface tab, and we're going to fill this thing, FILL, There we are. And that's my part. That's all I've got. Okay. Now, we're going to use a rosette. We're going to need a rosette later on, and rosette can be created later, or it can be done at this stage and use it. Although it's not called a rosette, it's called if I do it right now, it's not called a rosette, it's called the uh, uh, access system. Okay, so we go to the essentials once again. Here's an access system. Automatically it placed at the global origin. If you want, you can move this thing, and the way to move it is right click, you create a point, and it's going to move to that point. But I'll keep it like this, and I'm not going to make this thing current. I always uncheck this. All right, so we save this. Okay. Now we want to create our material properties according to that table that I showed you. So just bear with me for a second. Okay, so we go to tools, and notice that here we have material browser. We're going to say add a material or create a material. Give it a name. So I'm going to call it video, whatever is convenient for you. Chapter 4. I'm not going to add the thermal to it because this is a name. It can be anything that you want, so I'll just leave it the way it is. Well, maybe add thermal. Okay, thermal. Okay. Now, in the current version of 3D Experience, these two, if you activate this triangle, so these two are always checked. But if not, then we check it out. Okay. So what happens now? A material is going to be created with that name, but that's only a placeholder. It doesn't have any values in it. I haven't inputted any values in it. So that's what we're going to do. We're going to do next. Okay. So we're going to create our material properties. Now, there's two ways you can do that. One is uh, right here. This is the one that I created. Right here, if you right-click on it, you can start inputting the properties that you want. That's okay. But you can also apply this thing to that part and do this inputting of the data later in the part. Okay, I'll do that just like it's done in the book. So right-click. First, let's do the composite one. Okay, if you look at my data here, the thickness of the ply, I believe, was 0.06 inches. Okay, no, I'm sorry, 0.01 inches, and there's 6 of them. That's why it gives 0.06. But this is fine. 0.01 is what we want. Okay, so this is the one. Skewed thickness 0.01. Okay, and then we say okay, and put the cursor back there, right click, and let's do the simulation data. In other words, the moduli and shear modulus and things like that. Okay, so we go to structure, abacus multiphysics, mechanical, elastic, and elastic. Okay, now we are dealing with the lamina. We are using shell elements, so we're going to be using lamina, and these are the numbers that we're going to put in there. If you look at that table, that was 20 e to the 6. Okay, this one is 1.2 e to the 6. These are the same data that I have done in using chapter 2, by the way. A Poisson ratio is 0.25. Okay, and G12 was 800,000 psi, and these two are 400,000 psi. 1, 2, 3, 4, 5, and 4, 1, 2, 3, 4, 5. Okay, good. Now, if you want to input the what are these things? The thermal expansion coefficients. Now, you scroll down and you get the multiphysics right there. See that? Multiphysics coupling, thermal mechanical, and thermal expansion right there. Okay. Now, this is not isotropic. because we are dealing with an orthotropic, basically orthotropic properties. There's three coefficient of thermal expansion, okay, and a reference temperature here. So if you look at these, I have two coefficient of thermal expansion. The third one in the depth direction is not given to me, but I don't need it. I can leave it the way it is, or I can use, if you want, alpha 1 or alpha 2. It really doesn't matter. And this is the reference temperature. Now, the other thing I should tell you is that, do notice that the unit here is per degree Kelvin. Okay, so 1 over degree Kelvin. Now, it took me a while to find out how do you change the coefficient of thermal expansion unit-wise, because it's per degree Kelvin. So if you want to do it manually, you take these things and multiply it by 9 over 5, I believe, by 9 over 5, and you get it per degree Kelvin. But I realized that it's also hidden somewhere here. So let me go ahead. Let me say okay right now. Let me say okay. We're going to go back to that and fix it. So we go to, if you go to preferences, and under the place where you set your units, look at for temperature first. Temperature. Now notice that temperature is, I already changed it to degrees Fahrenheit, but underneath it, it is inverse temperature, per Kelvin. So it looks like this is the one that you want to do for thermal expansion. So not per degree Kelvin, you're going to change that to, oops, wait a minute, let me select this, per degree Fahrenheit, so that you don't have to do that manually. You say okay. Now let's go back here, let's see what happened. Right click, uh, simulation, and we already did this, right? And let's go to a temperature per degree Fahrenheit. So you don't have to multiply these things by 9 over 5 to get per degree Kelvin, as I've done in the book. But all you do is just straightforward, just put these things in. So the first one is minus 1.7 e to the minus 7. So this one is minus 1.7, minus 1.7 e to the minus 7. It took me a while to find this because I was looking for coefficient of thermal expansion. I couldn't find it in the preferences. So, but there's something inverse temperature. That's what this thing is. So, and this one is 1.5 e to the minus 5. 1.5 e to the minus 5. Positive. Okay. 1.5 e to the minus 5, and we are assuming that these are this one is, of course, I'll leave it as 0, really doesn't matter, but the reference temperature I'm assuming is 220 degrees. 220. That means the temperature at which these coefficient of thermal expansions are given. Now if these values were a different temperature, that's fine, just put that reference temperature over here. Okay, so this is all right, and we're good. Let's save everything. Now let me close that. Actually, let me save everything. Okay, so the next thing that I've done in the book is, okay, now that I created these properties, I will assign it to that part. Okay, so I'm going to say right click, put the cursor there, right click, you say apply. Unfortunately, I'm going to have to close this. I'm going to close that. I don't need it, but there's my part. Apply it to this part and make a check mark here, green check mark, and it's applied right here. Now I told you that this data could have been done at this stage. In other words, you could have just created the shell and applied it and then made changes here. Let's just check this for a second. Double click on this. Yeah, and one other thing I noticed that I forgot to specify this thing to be unidirectional, but that's a cosmetic change. It makes no difference because in the finite element stage, this is not important. It's not used, but for bill of material it may be. So I'm going to change that thing to unidirectional. It really doesn't matter. Okay. Notice that's just the correct thickness, and if you double click on this, you get the stuff that I inputted. Okay. So good. We already saved this thing. We just made that final change over there. That's cosmetic. You really don't need it. Okay. Now, what am I doing in the book? So after this, then I'm going to go to composite properties. So we go to uh, the robot, wait for the composite properties workbench to pop up right there. I'm going to select this. And close that. You you may be looking for, well, what happened? It didn't change. So click on this shape. Okay, let's try it again. So I double click on this, right? So I'm in the part design. So let's go ahead and bring our composite design workbench icon. Oh, right there. Okay, I already mentioned this thing. When you want to get into composite design workbench, make sure you're at the part level. Notice that now we're in composite design. Now, the first thing that we need to do, we're gonna use the zone method incidentally in order to create the plies, and this was done in chapter 4 also, chapter 3 also. Okay, but we'll worry about that later on. First of all, zone design. Click on zone design. Click on composite parameters. You add the material. Now you have to go and select that thing from your database, okay? The easiest way, notice that unfortunately I cannot pick it from here. The easiest way to arrange for that is the following. Let me escape this, escape that, cancel it, okay? So before I do this, I'm going to go to the robot and say apply material definition, because when I do this, any material that is in my session, and remember the part is in my session and I applied it, is going to appear here. And it's now that I can select that material from this this tab. Okay, so let's try it again. We go here, composite design. Are you there? Well, actually, I didn't have to do that because it was already in the background. It's the last one. Okay, fine. All right, so here's what we have. This is where we were, and we clicked on composite design parameters, add the material, library. Now notice that now I can go into this material tab, these are materials in session, and select this, okay? And when I do that, it populates the data here. And let me go back to right there. Okay. So what do we have? What else do we have? We have a rosette. We're going to select our rosette, add a rosette, and the rosette was created either from the tree or from the screen. I did it. All right. And what else? So lamina. We're going to create a laminate, as I've done in chapter 3. I'm going to create a laminate. Add a laminate. And my laminate is going to be the material that, here make sure you select the stacking sequence, because the other option is the thickness law. I'm going to use stacking sequence as was done in the book. Material is going to be what I created. And my orientation, if you look at it, I'm going to create the top three laminate, the 3 plies, or yeah, basically 3 plies, and then use a mirror to reflect it. So I'm going to do the first one. If you look at the table, the first one is going to be 0. What I'm saying is this. This is the top portion I'm going to do. This is okay, it doesn't matter. Let's see now. I can start from the bottom, right? From the bottom. So it's going to be plus 30. Oh, yeah, I forgot. Let's go back here. The problem is that I don't have plus 30 here. Okay, so I suppose I have to cancel that. We go to directions. We add directions. One of them is going to be, let's give it P30. That means plus 30. Let me actually write a plus 30. How about that? This is just a name, and the actual value is 30. And the color, I'm going to use this brownish color. Okay, I'm going to do another one, minus 30. With the minus 30 there, the first one is just a name. Okay, anything you want. And the color, I'm going to make it dark brown. Okay, All right, so I have these two directions. Now I go to laminate, add a laminate, and using the stacking sequence. So material is the one that you just created. The first one is 30. Okay. Okay. And if necessary, we're going to rearrange these later on. You'll see that. Add. Then another one. The angle is minus 30. Add. Then another one. Angle is 0. Add. So what I have done here, I have created these three. Okay, I've created these three. All right. And then because we want the same thing at the bottom or the top, we're going to mirror it, or symmetry, non-pivot. That means these things get repeated, including 0. And we say, okay, so we did create a laminate. If there are any mistakes, we're going to go and fix this thing. Okay. So that's pretty much it. So we created direction, laminate, rosette, and the material. We just say, okay, and we save it. Now, so let's go ahead and use the create the plies. Okay. The question is, well, first of all, this was just a material properties, composite parameters. Okay. Now we're going to we're in a zone design. You want to create a zone group, and then a zone, and then the plies. Okay. So here's a zone group. You click on it. The surface is right there. We keep the draping direction upward. Okay. Now, when I keep the drape the direction upward, the problem becomes that the first ply is going to be 30, and then the next one is going to be minus 30 probably. Well, we'll see. We'll see. Say okay. Good. Then we do a zone for group 1. For the boundary, we select that sketch. Okay. Notice that this is going to be my zone. Okay. Laminate, we're going to select lamina 2. The reason it says lamina 2 is because I did something that in the close changed it, so it really doesn't matter. Okay, 30 minus 30, 0, 0 minus 30, 30. That may be okay. So we say, or rosette automatically is picked. See that? Say okay. All right. So the zone has been created. Now we're going to create applies from zone. See that? Applies from zone. You click on it. Now, I wanted to create the plies for my zone group 1. Make sure you check this box, create plies without staggering. Okay, even if you don't check this thing, it will create the plies where it'll give you a warning message. So I'm going to check that, and we say okay. I better have 6 plies generated for me. So you look at the stacking engineering branch here, and there must be 6 plies in there. Now I want to see the order. So what I do, I just scroll down, go to my ply exploder. Now if I can see it, then just click on the review. Okay, there is a ply exploder. Ply group 1, apply. There. This is too much. Let's change the spacing to 40. 40, apply. Okay, good. So notice that it did create the plies for me, but it did it in a random way. It's not really random, but they have their internal process of calculating. And this is not what I want. Because remember, if you look at your drawing, it was 30, minus 30, etc., etc. So right now, 0 is at the very bottom. So what I do is, as I did in chapter 3, I can go through this one by one, through the tree, one by one, and change the angles. Okay, but there is an alternative way, maybe a faster way. That's a good idea to do, to know. So let me cancel this. Okay. So if you go to if you select the plies design right there, see that right there, plies design, there is something called ply table here. See that ply table on the plies design? I'll switch from zones design to ply design. Ply table. ply group 1, I wanted to create an Excel spreadsheet for me, which has all the information in it, the 6 plies, and then I go change it there, save it, and then import it back. Okay, so I did this. The question is, where do I want to put it? You select this 3 dots. It will take you location on your drive. So I'm going to call this thing video. How about video chapter 4? Chapter 4. Uh, ply table. Okay, ply table. So it's going to create that Excel file for me under that name associated with these plies that I just created. And we say OK or save. And notice that I'm asking it to open it for me immediately. So an Excel spreadsheet is going to open up with all the data from all 6 plies on it, right there. Plies 1, 2, 3, 4, 5, 6. And this is the orientation that I don't want. So I can change these the way I want. For example, the first one was plus 30. The next one was minus 30. The next one was 0 and 0 and minus 30 and 30. This is a lot faster and more efficient instead of me going through the tree one by one, change the angles. There are other ways to do it too, but this is fine. So make sure you save it. So that file that I created has this information. If you want, you can save it on a different name. It really doesn't matter. We close that. Now you're going to say ply table import. Go and find out where you want to take that import file. You go there. This is the directory that I put it in. And remember video chapter 4 ply table. And if I saved it on a different name, then click that. Yeah, select this. And we say OK. And we say OK. Okay, so let me check something here. Okay, let's go and use the Ply Explorer to see what happens after we imported that revised Excel spreadsheet. So there we are, apply, and notice that now it's in the proper order. Okay, so 30 minus 30, 0, 0, minus 30 and 30. Okay, so cancel that, we're good. Let's save everything. Now we're gonna move to the structure models creation. Okay, uh, use these default radio buttons, automatic. Okay, and notice that no elements are created. Okay, no elements are created, and we have to do that ourselves. So we go to let's do the mesh first, as I've done in the book. So mesh, and use a surface quad mesh right there. Select the surface and 0.125. This means 8 in the y direction and 32 in the x direction. But that's okay. Parabolic, okay, and just say apply or mesh. It'll mesh it for you. Okay, say all right. And now we're going to apply the composite properties. So we go to model. From mesh you go to model, and you use the composite shell section right there. The support is that surface, that fill surface. You can select it from the T or from the screen, fill. And we're going to do it by plies. We're going to, basically the composite, we're going to specify them by plies. It tells you that you had one ply group 1. Remember the 6 plies that you created? You select it. And make sure you scroll this thing down, okay? And for offset definition, use none. Okay, so basically what that means, none means that the, the, the surface is exactly halfway between the top and the bottom plot. Okay, all right. So we say fine. This is done. Let's save everything. All right, and now we're going to go to we're done here. So notice that these are shell elements are created, properties were assigned. Okay, and now we're going to go to scenario, structural model scenario creation, structural scenario creation. It's a structural problem. It's not thermal, it's structural. Okay, the fact that we are applying temperature, this is in the context of basically static. You're not doing heat transfer problem. Say okay. Needless to say, you get the two exclamation marks here. So we go to setup, select the finite element model. Immediately that gets rid of this exclamation mark selected. Say okay. Notice that this becomes green. Now we're going to go and do a step, procedure, static step. Now make sure you go to the advanced and uncheck the include geometric nonlinearity, okay? Because composite design analysis will not take that into account. So make sure you uncheck this. Don't worry about that. It's all linear problem anyways. Okay, now initial conditions, very important. You click on it, initial temperature. That is the oven temperature, 220 degrees. 220, because the sample came from the oven, okay? And we say, all right, okay. Now we go. Then we're going to go to restraints. Okay. Well, yeah. Let me go to load. Okay. Let me go to load. First of all, I don't want to see this mesh here. So right click, mesh visualization management. Don't show me the mesh. Okay. Very good. Now, by the way, I don't want to see this zone here. This is a zone. So let me hide it also. Okay. So this is my surface basically. That's the fill that I create. Fine. Now. If you say initial temperature, see that? Okay, so under the load, you select the load. Notice that in the load, if you scroll here, you see a prescribed temperature. That means the temperature at which we are trying to do the calculation, which is 70 degrees, the room temperature. So we change this thing to 70. That initial temperature was 2220. The prescribed temperature right now, which where we're going to calculate the deformation and everything, is 70 degrees Fahrenheit. Okay, and we say okay. This was the load basically. All right. Now we go to the restraint, and we're going to apply the 1, 2, 3 rule. The only thing is that there's a bunch of things here that maybe blocking our view. So first of all, let me hide this rosette. I'm going to hide all of these things. I don't need it. Just makes it easier. Hide, hide. Okay. Incidentally, this is the temperature that you specified. Okay, that has to do with that the temperature. You don't want, you can hide it. Hide this, and make sure you hide the sketch. Okay, because once the sketch is there, it won't let you pick that vertex later on to apply the 1, 2, 3 rule. So hide the sketch. All right. Now we're going to go do fix displacement at this corner point. X, Y, Z, the all restraints. At this other corner point right there, the X and Z are restrained. And finally, this last one right here, only Z is restrained. So this is the 1, 2, 3 rule that has been applied. And I'm pretty sure we did everything that's needed here. Yeah. Okay. So let's save everything first. All right. I will go to the simulation. First do the model and scenario check. there are any warning messages, error messages, it'll pop up here and you catch it before it runs. So obviously there is something went wrong. Okay, right here, this is very important. It is hard to see what this guy is saying. The reason is that uh, uh, the thing that I picked to apply the 1, 2, 3 rule was not actually a vertex. Something was blocking that, and I inadvertently picked that, and it says that, look, you put a restraint on a point that basically doesn't have a mesh associated with it. We say, fine. So here's what I'm going to do. I'm going to cancel that. I'm going to cancel this. Okay. And just to make sure that we don't make similar mistakes, so what we're going to do is uh, here's what I'm going to do. I'm going to delete these. I'm going to do it again, but delete these. Okay, so let's see now, where are we? Okay, so scenario right there. Oh, sorry, restraint up there. We have to delete it from here. Delete it from here. Delete it from here. It's easier if I delete it and did it again. Delete it. Now, I bet there's some stuff here that I picked which is not a vertex. So let's go ahead and hide a bunch of things. We already hit the sketch. Let us hit the, let's say the plies. Let's hit the plies, hide the plies. Okay. And I bet that was the one that was causing the problem. Okay. So I took the corner, which was the corner of a ply. Okay. So let's go ahead and apply a restraint again. Fix this placement. Let's try it again. This point, all three. This is why in the book I'm saying hide a bunch of stuff that will prevent you from picking things, or it may let you pick, but it's not the stuff that you want to pick. It's the corner of a contour of a ply, for example. And that one, okay, in the Z, all right, save everything, go back to simulate, check it out, you see? Instead of running the whole thing, we do these preliminary ones instead of going there and getting error messages. This is a simulation check. All right, doing it. There is a warning, but as long as there are no error messages, we let it run. This is a bad habit, but that's what I do. Okay, this is done. And now we're going to run it. This icon here, this looks like thermometer. It has to do with that probably initial temperatures that are applied. I'm glad that actually this happened to us, that it didn't run, because in the book I keep saying hide this, hide this, hide this, but that's for a reason. Okay, either you cannot pick that entity, or you pick it but it doesn't belong to the finite element entities. Okay, very good, finished. So let's close this. Nothing exciting for load step 1 because there is no load applied, and let me close that too here. Okay, let's look at the frame 1. There we are. Look at what happens. This problem, that guy, that sample just shrinks. Okay, it did shrink. You can see that. Go here. This is the original thing. It shrinks. Okay, and it also stretches, of course. Okay, so if you look at the one and the von Mises stress constant, nothing exciting here, because in a problem like that, within each laminate, which is each lamina or ply, you have constant stress. Okay, please check the book. And if you look at the displacement, there we are. Okay, and you can animate it to see actually it does stretch. Yeah, not stretch, you mean shrink. Okay, shrink in both directions. Okay, that'll take care of it. Good luck. Take care.